Remember being a kid? Remember looking up? Remember seeing a helicopter? I do. Not just any plane, but a helicopter. There's something about helicopters that captivates the imagination, isn't there? Maybe it's their ability to take off vertically. They don't need a runway, they just rise, defying gravity. Or maybe it's the mesmerizing dance of their rotors, those giant blades slicing through the air. They look powerful and graceful. All at once. As a kid, I'd spend hours watching helicopters. I'd marvel at their ability to hover in mid-air. They seemed to hang there effortlessly, like a hummingbird sipping nectar. And then, with a slight adjustment, they'd shoot off in another direction. Get ready for a wild ride. At its core, a helicopter is a marvel of engineering that uses spinning rotors to achieve both lift and thrust. These rotors, essentially large airfoils, are the beating heart of the helicopter. They're what allow it to perform its unique aerial maneuvers. Unlike airplanes, which rely on fixed wings and forward motion for lift, helicopters generate lift by rotating their blades. This rotation creates a difference in air pressure. The air above the rotor blades moves faster, creating lower pressure. Meanwhile, the air below the blades moves slower, resulting in higher pressure. This pressure differential generates an upward force called lift. By tilting the rotor plane, the direction of the lift force changes, propelling the helicopter in that direction. It's no wonder they've become indispensable in so many fields. From search and rescue missions to military operations, from transporting goods to aerial photography, helicopters have become essential tools in our modern world. They allow us to reach places that are otherwise inaccessible. They provide us with a unique perspective from the sky. Get ready to see the world from a whole new perspective. Right then, let's get down to brass tacks. To truly understand how a helicopter works, we need to get up close and personal with its bits and bobs. Imagine a symphony orchestra. You've got your strings, your brass, your percussion, all working in harmony. A helicopter is much the same. It's a symphony of engineering, with each part playing a vital role. First off, you've got the fuselage. That's the main body of the helicopter. Think of it as the chassis of a car. It houses the passengers, the engine, all the important stuff, and let's not forget about the tail boom. Now, let's talk rotors. These aren't just any old spinning blades. They're marvels of engineering, designed to manipulate the air with incredible precision. Think of them as the helicopter's wings, only much more dynamic. There are two main types of rotor systems, the main rotor and the tail rotor. The main rotor sits on top of the helicopter and does the heavy lifting, literally. It's responsible for generating the lift that gets the helicopter off the ground and keeps it there. The tail rotor, on the other hand, is a smaller rotor mounted on the tail boom. Its job is to counteract the torque produced by this spinning main rotor. The tail rotor pushes against this torque, keeping the helicopter pointing in the right direction. Clever, eh? Now, let's have a closer look at these blades, shall we? They're not just simple slabs of metal, they're carefully crafted with a slight curve on the upper surface and a flatter underside. This shape is crucial as it forces the air flowing over the top of the blade to travel faster than the air underneath. The faster moving air over the top creates an area of low pressure, while the slower air underneath creates an area of high pressure. Nature always tries to balance things out, so the high pressure air pushes upwards towards the low pressure area, generating lift. By changing the angle of the blades, the pilot can control the amount of lift generated, as well as its direction. Tilt the blades forward and the helicopter moves forward. Tilt them back and it goes backwards. Tilt them to the side and guess what? Yep, it moves sideways. Let's get back to those mesmerizing rotors, the heart of the helicopter's magic. Picture them as giant fans, slicing through the air with incredible power. But there's more to it than just spinning. These blades are cleverly designed to exploit the principles of aerodynamics. The shape of a rotor blade is crucial. It's what we call an airfoil. It's curved on the top and flatter underneath, much like the wing of an airplane. And that, my friends, is what we call lift. Lift is what gets a helicopter off the ground, but how does it move forward, backward, or sideways? Well, that's where things get really clever. Remember how I said the angle of the rotor blades can be adjusted? That's the key to helicopter maneuverability. By tilting the entire rotor plane forward, the lift force generated by the blades is also tilted forward. This creates a component of the lift that acts in the forward direction, propelling the helicopter forward. Similarly, tilting the rotor plane backward creates a backward thrust, slowing the helicopter down or even making it move in reverse. Tilting the rotor plane to the side creates a sideways force, allowing the helicopter to move laterally. It's all about manipulating the direction of that lift force. Now, you might be wondering how the pilot actually controls the angle of these rotor blades. Well, it's all thanks to two ingenious mechanisms, the collective and the cyclic. Think of them as the steering wheel and the pedals of a helicopter. The collective is a lever located beside the pilot's seat. Pulling up on the collective increases the pitch angle of all the rotor blades simultaneously. This increases the overall lift generated, making the helicopter climb. Pushing the collective down decreases the pitch angle, reducing lift and causing the helicopter to descend. The cyclic, on the other hand, is a control stick that looks and feels a bit like a joystick. Moving the cyclic tilts the entire rotor plane in the desired direction. It's a delicate dance between the collective and the cyclic. Now, let's talk about a problem that arises from all this spinning. Imagine you're trying to spin a bicycle wheel with your hand. You'll notice that your hand naturally wants to twist in the opposite direction. This is due to a physics principle called torque. The same thing happens with a helicopter. As the main rotor spins, it creates a torque that wants to spin the entire helicopter in the opposite direction. Not ideal if you're trying to fly in a straight line. That's where the tail rotor comes in, like a trusty sidekick. It's a constant battle of forces, but one that the tail rotor is designed to win. But the tail rotor does more than just counteract torque. It also plays a crucial role in controlling the helicopter's yaw. Yaw, in simple terms, is the helicopter's rotation around its vertical axis. Think of it as turning your head left or right. The pilot controls yaw using pedals on the floor of the cockpit. Pushing the left pedal increases the pitch of the tail rotor blades, generating more thrust. This causes the tail to swing to the right, turning the helicopter to the left. The tail rotor is all about subtle adjustments. So there you have it. We've got the collective controlling the amount of lift. We've got the cyclic controlling the direction of lift. And we've got the tail rotor counteracting torque and controlling yaw. It's a complex orchestra of levers, pedals and gauges, all working in harmony to keep the helicopter aloft and under control. But here's the thing, for a skilled pilot, it becomes second nature. It's like learning to ride a bike. Right then, let's talk about what these whirlybirds actually do. They're not just for show, you know. Helicopters have become indispensable tools in a wide range of fields, from emergency services to scientific research. Take search and rescue, for example. Imagine a hiker stranded on a mountain ledge or a boater lost at sea. It's the helicopter that comes to the rescue, hovering overhead while a rescuer is lowered down on a cable. They can reach places that would be impossible for ground vehicles or even boats to access. Talk about a lifesaver, literally. And then there's their role in fighting fires. Helicopters equipped with giant buckets can scoop up water from lakes and rivers, then drop it precisely onto the flames. They act as aerial firefighters, protecting lives and property from devastating blazes. Section 2. Whirlybirds at work, industry and construction take flight. But helicopters aren't just limited to saving lives and exploring the unknown. They've also become essential tools in various industries, from construction to transportation. Ever seen a helicopter carrying a giant load dangling from a cable? That's not an unusual sight in the world of heavy lifting. Helicopters are used to transport massive objects like construction materials, power line towers, even prefabricated buildings to locations that are difficult or impossible to reach by road. Think about building a bridge over a wide canyon or erecting a wind turbine on a remote mountaintop. It's the helicopter that makes these feats of engineering possible. In the oil and gas industry, helicopters transport workers to offshore drilling platforms and back, often in challenging weather conditions. They provide a lifeline to these isolated outposts, ensuring the smooth operation of these vital energy sources. And then there's the world of agriculture. Helicopters are used for aerial spraying of crops, applying fertilizers and pesticides with incredible precision. This helps farmers increase yields, protect their crops from pests and diseases, and do it all while minimizing environmental impact. They're also used for aerial surveillance of crops, using specialized cameras and sensors to monitor plant health, identify areas that need attention, and optimize irrigation and fertilization strategies. Talk about a bird's eye view of agriculture. Section 3, the future is vertical helicopters in the 21st century. As technology continues to advance, helicopters are only becoming more versatile and capable. We're seeing the emergence of new designs like electric helicopters and autonomous drones that promise to revolutionize air travel and transportation. Imagine a future where you can hail an air taxi, hop into an autonomous electric helicopter, and soar above the traffic congestion below. It sounds like science fiction, but it's closer than you might think. Companies are already developing these types of aircraft, and some are even conducting test flights. The military is also exploring new applications for helicopters, such as unmanned drones for reconnaissance and surveillance missions. These drones can operate in dangerous environments, providing valuable intelligence without risking human lives. And let's not forget about the role helicopters will play in space exploration. NASA is developing a helicopter called Ingenuity, which is currently exploring the surface of Mars. It's the first aircraft to achieve powered, controlled flight on another planet, paving the way for future aerial exploration of other worlds. From saving lives to building bridges, from fighting fires to exploring Mars, helicopters have come a long way since their humble beginnings. They're a testament to human ingenuity, a symbol of our ability to defy gravity and conquer the skies. So next time you see a helicopter thundering overhead, take a moment to appreciate the marvel of engineering and the countless ways these incredible machines are shaping our world. Section 1, the enduring allure of the whirlybird. So there you have it. We've delved into the guts of these mechanical marvels, these sky-dancing whirlybirds. We've seen how those spinning rotors, those blades of glory, cheat gravity, generating lift from thin air. We've explored the delicate dance of controls, the collective and cyclic, like a pilot conducting an orchestra of forces. And we've witnessed the tail rotor's balancing act, keeping everything in check, a silent guardian against the chaotic forces of torque. But it's more than just the mechanics, isn't it? There's a certain magic to helicopters. That ability to take off vertically, to hover mid-air, to dart and weave through the sky. It captures our imagination, stirs something primal within us. Perhaps it's the dream of flight, of freedom, of seeing the world from a different perspective. And let's not forget their practical applications. From saving lives to transporting goods, from fighting fires to exploring the unknown, helicopters have become indispensable tools in our modern world. They are a testament to human ingenuity, a symbol of our ability to overcome challenges and reach new heights, literally. Section 2, Upward and Onward, the future of vertical flight. But the story doesn't end there. The future of helicopters is just taking off, and it's looking bright, fueled by innovation and driven by our insatiable desire to push the boundaries of what's possible. We're on the cusp of a new era of vertical flight, one where electric helicopters and autonomous drones will transform urban transportation, making air taxis a reality. Imagine a world where commuting means soaring above the gridlock, where packages are delivered to your doorstep by silent, emission-free drones. Imagine emergency responders arriving at the scene in the blink of an eye, unhindered by traffic, ready to provide aid where it's needed most. And as we venture further into the cosmos, helicopters will play a crucial role in exploring other worlds like Mars and beyond. They will be our eyes in the sky, our scouts on alien terrains, helping us unravel the mysteries of the universe. The future of vertical flight is full of possibilities, limited only by our imagination. And as we continue to innovate and explore, one thing is certain: the allure of the whirlybird, the dream of defying gravity, will continue to inspire.